Okay, so you've probably seen how to solve a trigonometric equations like tangent of x equals 4. Well, so that's no problem. You just treat x like an angle and you figure out what angles it could be and then you're done. Well, here we're going to look at what if you have a multiple angle. So for example, instead of x, let's say you have the tangent of 5x equals 4. Well, it's still not bad. What you do first is you try to determine what angles 5x could be, then solve for x, right? Because ultimately, when you have an equation like this and the variable's x, your last step should be x equals dot dot dot. Okay, so there are two parts to this: to figure out what 5x is, and then determine what x is. So let's get started. So what we'll do is we'll sort of look at, so I'll label this, the angle that we're dealing with is 5x, and the tangent of this angle is 4. So you could think about 4 over 1, and this would be opposite over adjacent. So we need a reference triangle where the opposite side is 4 and the adjacent side is 1. Well, that could happen in the first quadrant or the third quadrant, where you get a positive ratio of 4 to 1. Okay, tangent's positive in the first and the third quadrants. So the reference angle here in each of these reference triangles, so the reference angle is tan inverse of opposite over adjacent. So tan inverse of 4 over 1, or just 4. So what that tells us is 5x could be any angle that lands here or any angle that lands here. Well, I noticed that these two angles are separated by pi this way, and they're also separated by pi this way. So I could represent every angle that lands up here or down here with one statement. The angles here would be the first angle from the positive x-axis to there would be tan inverse of 4. It is the reference angle. And then to get to the next one, I would add pi. And then to get back, I'd add pi again. So all I have to do to represent every angle I've got shown here would be to add pi k to the tan inverse of 4. Now, that's an angle. What angle does it represent? Well, it represents the angle 5x. So now I've learned about this. I can come back over here to my equation, and I can say that the angle 5x has to equal tan inverse of 4 plus pi k. By the way, this is your exact reference angle. Sometimes it's useful to put this into a calculator in radians mode and get a decimal radian measure of this too. So depending on what these instructions say, if you want to round it, you plug it into your calculator. If you don't want to round it, you leave it like this. All right, so 5x equals this angle, or any of these angles. Now I need to solve for x. So I learned about my angle first, and now I can easily solve this for x. I divide by 5. So divide both sides by 5, and I get x equals, and we'll write it kind of differently. Let me write it all out, I suppose. Tan inverse of 4 plus pi k, all of that divided by 5. Now, a more beneficial way to write this perhaps would be 1/5 tan inverse of 4 plus pi k over 5. So basically you're going to have this, and you're going to add integer multiples of pi over 5. So 1 pi over 5, 2 pi over 5, 3 pi over 5, and you could add the negative ones also, negative 1 pi over 5, negative 2 pi over 5, etc. And those will be specific solutions to this equation. But that's what x equals. You could write it the same way this answer for x is also acceptable. This may be more beneficial. You're sort of separating uh, the multiple parts that you're adding to some starting point by writing it in the second way. Let's try one more just to make sure we fully understand this. Okay, so you see this equation, and we've got the sine of this angle. Now, a lot of people like to think about trying to multiply by 2 or something to get rid of this. The problem is when you multiply by 2, it's not going to go inside and multiply the angle by 2. It's going to multiply the whole function by 2. So be careful with that. The first thing you want to do here is isolate the trig function. So we're going to subtract the square root of 3 and divide by 2. And we see that we have the sine of this angle equals negative square root of 3 over 2. Now, this is clearly going to be a 30, 60, 90 triangle. So instead of, we can use our sine inverse, and that's what we'll do first, but I'll mention that it can be easier than that. So what we're going to do is this sort of strategy. We're going to learn about the angle theta over 2, whatever the angle is, in this case it's theta over 2, and then solve for theta. Because our goal eventually is to get theta equals da 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 da, whatever. So that's what we're going to do. We have to go through a two-step process though. We have to first learn about theta over 2 and then we can solve for theta. Alright, so let's do that. So the angle here is going to be theta over 2. Sine is negative on the bottom two quadrants. And I know my reference angle in each case is going to be sine inverse of square root of 3 over 2. Now, you can leave it like that if you like. However, sine inverse of square root of 3 over 2, since it's a 30, 60, 90 triangle, is simply pi over 3. Okay, so every angle that lands here, well, what angle gets you from here around to there? Well, you go to pi, and then you add the reference angle, which is pi over 3. So this is 4 pi over 3. Similarly, this is 5 pi over 3. And then to get from one angle to the other is not equal to go from this way and then to go back to the other one. So we can't write this as one statement. Okay, so don't try to attempt that as we did in the last example. So every angle that lands here would be 4 pi over 3 plus 2 pi k. And every angle that lands here would be 5 pi over 3 plus 2 pi k. Okay, great. So that's what theta over 2 could be. So now I can say theta over 2 equals 4 pi over 3 plus 2 pi k, or theta over 2 equals 5 pi over 3 plus 2 pi k. And now I need to solve for theta, right? My final step needs to be get theta by itself. So in this case, I will multiply both sides by 2. That's going to give me theta on the left side. So I'll have theta equals, and I'll distribute my 2, so I'll have 8 pi over 3 plus 4 pi k, or theta equals 10 pi over 3 plus 4 pi k. So those are my solutions for theta, and I had to first find out about the angle that's given, which was theta over 2. Okay, so there's another example. I hope it makes sense. I wanted to show you one where when you apply the inverse, you actually get a nice angle. In this case, it was in a 30, 60, 90, and in fact, it was a 60-degree angle, or pi over 3 as a reference angle. So you could leave it as sine inverse if you prefer, but just realize that if you know the inverse, then you might as well just go ahead and use it.